So the thing you didn't understand from the slides,
It was the welfare in the silent model.
yeah, okay. Could I take this? It's the easiest. So let me just make a note of a few things. Okay, so each firm is making profits of.
Which slide are we looking at?
It's page 17, entry in the salad model.
Oops. That was your last section.
Yeah. It's just this thing. So the thing I have on the slide is the integral way of doing it. And what you drew here is the other way you can do the same thing. So each of these, this is just a section between two firms, okay? Well, let's say a section between three firms. So these firms are a distance 1 over n between each other. Okay, so this distance is 1 over n. There's going to be a different consumer here and then a different consumer here. So all the guys in this region will buy from the firm in the middle. Let me give you this back.
Cheers.
So this distance is 1 over 2n. This distance is 1 over 2n. If you're located, so all these people are buying from this firm here, okay? If you're located where this firm is, you don't have to walk anywhere at all. Okay, so but people there pay 0 transport costs. People here are as far away from the firm as they possibly could be. Okay, so how far are they going to walk? Well, they have to walk this distance 1 over 2n. So they're going to pay a transport cost of t over 2n. If you're someone, in fact, if you're someone who's a difference distance x from the firm, you pay this transport cost tx. Okay, so the total transport cost paid by all of these people, if you like, I can relate the two ways of approaching this. It's the integral from the minimum distance, which is 0, if you like, up to the maximum distance here, which is 1 over 2n, of p times x dx. Does that make sense? Okay, so the total transport cost paid by the people in this interval is given by this integral. Okay, people at 0, people there are walking no distance, people there are walking a distance 1 over 2n, people in between are walking a distance of x, and they pay a cost of tx.
Do you need to times that function by 2 because it's on both sides?
Yeah, we will do. Yeah. So this is just for that bit. If you times it by 2, like you said, you get all of the people who buy from this particular firm. In total, there are n firms. Okay, so if you times it by n, then you get the total transport cost. So this integral, well, you could do this integral, or you could just think of it as a triangle. We've got a base of 1 over 2n. We've got a height of t over 2n. Okay, so the area of this triangle is going to be t over 8n. So we've got 2 times n times t over 8n, which is n, which is t over 4n, which I hope is what I had in the slide.
Yeah.
Does that make sense?
Yep.
Can the n cancels out?
What?
The n.
Oh yeah, the end cancels out. Ah, so yeah, sorry. So this was 8n squared. So we had 1 over 2n times t over 2n. So you got an n squared on the bottom. So. Okay. There we go, exercise 12.1. Okay, yeah, this one is a good one to go through. Have we done? We still haven't got as far as vertical differentiation, have we?
No.
We're running a bit behind in the lectures. So did you read about vertical differentiation in the book before having a go?
I just sort of went through the slides.
Yeah.
Yeah, it's in the book as well, but it doesn't
The slides
explain.
we haven't got to yet.
Haven't we? Oh.
But for ones on vertical differentiation, you went through.
Yeah.
Yeah. Okay. Okay. Well, we can go through this. We'll do it in tomorrow's lecture, I guess. Vertical differentiation. But this is worth doing. Okay. So consumers have preferences given by 12.8 and 12.2. Okay, so consumers are located on this interval from 0 to 1, and for two brands, A and B, and their utility. Okay, utility of a consumer located at point X, buying brand I is AX minus PA or BX minus PB. Okay, so there are two brands they can buy, and one is higher quality than the other, if you like. So X, if you like, measures how much they value quality, and we have A is less or equal to B. So, you know, think about the consumer located at 1. B is bigger than A, okay, so he's going to really value this good B. Whereas the consumer located at 0, the X is 0, these two things are both 0, so he doesn't really care about which one to buy, he's indifferent between the two. Okay, so the first part of the question says, show that the number of consumers who do not purchase any brand equals PA over A. So when would a consumer choose to not to buy anything at all?
When the sell price of A and B are above their valuation for both.
Yeah, okay. So in the setup of this question, they always have the option of getting 0 utility by not buying anything. So when are they going to choose not to buy anything?
When AX minus PA is less than 0.
Yeah, okay.
And the
So
same for PA.
yeah.
plus PB.
Yeah. So if you like, we can find the indifferent consumer, the consumer who's just indifferent between buying a good and not buying a good. So they're going to satisfy, or there's going to be a different consumer who's just indifferent between buying A and not buying anything, and one who's just indifferent between buying B and not buying anything. Okay, so naught is going to be equal to AX minus PA. So putting PA on the other side and dividing by A, we have this XA is PA over A. And you know, there could be a kind of an indifferent consumer for B as well. So XB is going to be PB over B. A is so it's going to depend on it's going to depend on what prices these guys set. You know, so we could potentially be both. Do not purchase any brand is PA over A. Okay, so we got two potential indifferent consumers. We want to show that in fact only these consumers. We want to show that the relevant indifferent consumer is this one. So what we expect to happen is that guys in this interval buy nothing. Guys in this interval will buy from A. Guys in this interval will buy from B. Okay, B is a kind of a high quality brand, if you like. We expect PB to be bigger than PA. But to do that, we need to solve the original problem. So the exercise is relying on you having already solved the problem where there wasn't this possibility of not buying anything at all. So maybe we should step back a bit and solve that first. Okay, so if you're for a consumer to be indifferent between buying from A and B, it must be the case that A X star minus PA is equal to B X star minus PB. Okay, so we can, you know, just as in a standard hoteling setup, so, you know, this is this kind of X star. We can use this to solve for where an indifferent consumer would be, if there was one. Okay, so putting PA on the other side and then dividing by A, well, we have A minus B X star, if you like, is PA minus PB. Okay, so X star is PA minus PB, and A minus B. So if you're to the right of X star, let's just check this logic is correct for people to the right of X want to buy from B, not A. If you're to the right of X star, then okay, so if X is bigger than X star, okay, then X is bigger than X star. What does that mean? Well, that means that X is bigger than PA minus PB over A minus B. And we can kind of undo the steps we did here, if you like. So you can multiply by A minus B. So A is smaller than B in the setup of the question. So A minus B is negative. So this, when we multiply by A minus B, we have to flip the sign. Okay. So A minus B is going to be X times A minus B is going to be less than PA minus PB. and then we can just rearrange to get back to what we started with, kind of. So AX minus PA is going to be less than BX minus PB. So what have we shown? Well, if you're to the right of the of this x star, x is bigger than x star, so going through this, we've shown that your value from buying from firm B is strictly bigger than your value from buying from firm A. So this picture is kind of right, okay, but people to the right of this x star guy are going to want to buy from firm B. Okay, so if anyone's going to be buying nothing at all, it's got to be these people who would otherwise be buying from firm A. Okay, so the answer to the original question of who's going to buy nothing at all, well, it's going to be given by this equation. Okay, so this will be x. As long as this thing is smaller than that thing. But it should be. And then the rest of the question is just solving for the behaviour of the firms here. Okay, so what's the demand faced by firm A? Let me rewrite this actually, it's the other way round so we don't get confused. The two things are the same. Okay. But this is positive now, so it's so easy to see what's going on. So which consumers, how many consumers are going to buy from firm A?
X star minus the people that don't buy anything.
Yeah, so x star minus this xa thing. So it's going to be PB minus, so let's call it QA. It's going to be PB minus PA over B minus A minus XA, which is PA over A. Yeah, let's leave it like that. And then who's going to buy from firm B? How many consumers are going to buy from firm B?
1 minus that expression.
This expression?
Yeah.
So what's 1 minus this expression would be, so this expression is this interval, so 1 minus it would be that interval plus that interval. So it's just going to be 1 minus x star, right? It's these people. It's all of this minus that. So QB is going to be, maybe that's what you meant, 1 minus PB minus PA over. Okay, so what should I'll keep the word of it. But xa is PA over A, and x star was PB. Okay, so we've got the quantities that both firms are selling. What we've got to do is find out what price they'd like to set. So profits, I presume marginal cost was 0 in the question. So profits are just price times quantity. The profits of firm A are PA times all of this. Okay, let's just write PA QA. Okay, so first order condition is going to be derivative of this times that. Okay, so QA plus this times the derivative of that, so PA dQA dPA. And dQA dPA is, so we get a we get a minus 1 over b minus a here, and we get a minus 1 over a there. So this is minus 1 over b minus a minus 1. Okay. So you can solve this for the price. Well, the price is in two places, isn't it? So the price is inside this QA expression as well. So let's just expand it a bit. So all of the things over, let's collect all of the things over b minus a to start with. Okay, so we have pb minus pa over b minus a, and then we also have a minus pa over b minus a there. Okay, so minus 2 pa over b minus a. And then all of the things over a, well, we have a minus pa over a, and then we have another minus pa over a, so we have minus 2 pa over a. So this is giving you can solve this for PA, and this is giving the reaction function for the first firm. Let's do the same thing for firm B. Okay, so pi b is pb qb, so yours is qb plus pb dqb. So this is qb plus pb times, okay, so derivative of qb with respect to pb is minus 1 over b minus a. Okay, minus 1 over b minus a. And again, let's expand this because we know what QB is. Okay, so this is going to be equal to 1 minus. So we've got a. Is everything okay?
Yeah.
So we've got a PB minus PB minus PA over B minus A from here, and we've got a minus PB over B minus A from here. Okay, so it's 1 minus 2 times PB minus PA over minus A. That's right. So we've got two equations now in two unknowns. We just have to solve them to find what the prices are. What's going to be the easiest way to do this? So this one is probably the easiest one to work with. So from this equation we have so this is equal to naught, right? So if we add this to the other side and then times by b minus a, okay, we have 2pb minus pa is equal to b minus a. I think that's right, yeah. So pb is equal to half of pa plus b minus a. And then once you have this, you can just substitute this into this equation. I think this is right. So naught is equal to, so PB is this thing, so half PA plus B minus A minus 2 PA all over B minus A minus 2 PA over A. And you know, this is just linear in PA. We just want to collect all of the PAs together. So we have naught is equal to, so we have half over b minus a PA there. We've got minus 2 over b minus a. So half minus 2 is minus 3 over 2. Okay, so we have minus 3 over 2 over b minus a. And then we've got a minus 2 over a, minus 2 over a times PA. And then we have everything else that's left over. What's left over? It's only this term that's left over, so we have half b minus a over b minus a. So that's just a half plus a half. Does that make sense? I haven't noticed that. So this thing is all negative. Let's take it across to the other side. So this is just 3 over 2 over b minus a plus 2 over a times PA is equal to half. So PA is equal to half over this thing. And if you times top and bottom by a half here, you can simplify this a bit. So this is half on the top becomes a 1. 3 over 2 becomes a 3. 2 becomes 4. Yeah, okay, and then, well, I guess you can further simplify by multiplying top and bottom by a times b minus a, if you wanted to, which would give PA is a b minus a over 3a plus 4 b minus a. So that's a b minus a. What's this? So we've got 3a minus 4a, so that's minus a, so 4b minus a. Is that the answer in the book?
So what did you do to the bit where you've got PA equals 1 over... Did you times that by half, did you say?
Times by 2, yeah.
Times by 2.
Yeah, it was. That was a half. Let me just see if I've got this right. PA is a times b minus a over 4b minus a. Thick. So it's easy to make a slip with this stuff. But then once you got this one, once you got PA, you had this expression for PB here. So you just substitute that one into PB. And then you're done. I think that the important thing with this exercise was being able to solve not just for the indifferent consumer, but for this normal indifferent consumer, but also for this consumer who's just indifferent between buying something and not buying something. Anything else you want me to go over? Did that make sense? You know. And then if you wanted profit, well, you've got the price, you've got an expression for quantity, down here you substitute prices into quantities, and that gives you the quantities, and then you substitute that into profits. what else did we do last week? Is there any X's and O's? We're really behind, aren't we? You were happy with the Dixit-Stiglet stuff? Is it worth going through an exercise on that? The week before last? No? Yes?
Was there a question in the book for that one?
Should have been. So it says 76234. It's only an example in the book about it. So Oshai section 7 2. Maybe it wasn't a good exercise. So, well, maybe we can go through one of these other questions from the book. Yeah, so Dixit-Stiglitz ends up being very similar to what you've seen with Monopoly. Once you get past once you've derived the demand curve, it then just becomes a standard Monopoly problem, right? So that's not too much today. Okay, so what about this? So this is question exercise 3 from 7.6. 7.6 exercise 3. So for fast food restaurants at the end of a road of length 1, but the wind blows from right to left. Hence, for transportation cost for a consumer who travels to a right is R dollars per unit of distance, and only $1 per unit of distance for a consumer who travels to the left. Okay, so that's an interesting variant, isn't it? So if you go this way, you pay R per unit. But if you go this way, you just pay 1 per unit. And we're told that naught is less than P1 minus R. If you give away the game, less than P2 less than 1 plus P1. Okay, so how would we go about solving for the location of a different consumer here? So let's call this price PA, let's call this one the price PB. So where's the indifferent consumer going to be? So if if you're located at X, what's your cost from buying from firm A?
X.
Yeah, PA plus X. And what's your cost for buying from firm B?
RX plus PB.
Is it RX?
1 minus X
Yeah,
times
exactly.
R.
Yeah, so R times 1 minus X. So then it's just a standard thing. We just have to solve for X star again. So we've got we've got a 1 X star here. We've got minus R X star here. Okay, so we have 1 plus R X star, and that's going to be equal to R plus PB minus PA. So X star is going to be equal to R plus PB minus PA over 1 plus R. So do we understand why they gave us these inequalities? Well, we say PB is less than 1 plus PA. No, that doesn't come up anywhere. Have I got this the wrong way round or something? Restaurant 1 is on the left, restaurant 2 is on the right. Travels to the right is R, travels to the left is 1. So this thing is let's just check this to make sense. So this thing is certainly positive, 1 plus R. This thing is positive if this thing is bigger than that thing. Oh look, PA minus R. We know that PA minus R is less than PB. So if we add this to that side, subtract this thing from that side. So we have 0 is less than plus R minus PA, R minus PA plus PB. Yeah, that's what we have here, isn't it? Okay, so this inequality is telling you that this bit's positive. So this is at least bigger than 0. The other thing we want X to be is less than 1 for it to make sense. You can't have an indifferent consumer that's on the other side of the line. So when is this thing going to be less than 1? Well, X star is less than 1 if and only if we multiply both sides by 1 plus R, we have R plus PB minus PA is less than 1 plus R. So this thing is true if and only if when we subtract R it's still true, so PB minus PA less than 1. And this is true if and only if PB is less than 1 plus PA. But we're told that PB is less than 1 plus PA. So their assumption has just told us that that X star is between 0 and 1. That's all their assumption is telling us. Does that make sense? So what prices would these people like to set? I'm not sure that's what the question asks you to do, but it's the obvious thing to look at. Okay, so the profits for firm A, well that's PA times X star. Okay, so the first order condition is going to say derivative of this times that, so X star plus this times the derivative of that, PA times derivative of X star with respect to PA. Okay, and that's just X star plus PA times, what's this thing? So the derivative of X star with respect to PA is minus 1 over 1 plus R. Minus 1 over 1 plus R. Okay, and then substituting in what X star was as well. So we have x star has a minus pa over 1 plus r. We've got another minus pa over 1 plus r there. So this is just r plus pb minus 2 times pa over 1 plus r. And then same thing for firm B. Profits of firm B are pb times x star. Okay, so no. Oh, no. What have I done wrong? What's wrong with that?
1 minus?
Yeah. So, again, the same thing. We have derivative of this times that. Okay, so 1 minus x star plus this times derivative of that. So pb times the derivative. So minus pb times derivative of x star is equal to pb. Okay, which is 1 minus x star minus pb times. So derivative of x star with respect to pb is 1 over 1 plus r. 1 over 1 plus r. Okay, so we have, this is 1 minus x star, which, yeah, so minus all of this, and then also minus another pb over 1 plus r. Okay, so this is just going to be 1 minus r plus 2 pb minus pa over 1 plus r. So you've got an expression here, naught is equal to this thing, naught is equal to that thing. So now we just have to solve for A and B. So this one's the easier one to do, right? Because if naught is equal to this, then you can just get rid of the thing on the bottom. Okay, so you know, if you times naught by 1 plus r, you get naught. So we have that naught. And then if we add that on both sides, so we have 2pa is equal to r plus pb. So pa is half r plus pb. And then you can substitute that into this expression. Okay, so if we take this to the other side and then multiply by 1 plus r, this is saying 1 plus r is equal to this thing is r plus 2pb minus PA, which is this thing, which is R plus PA. So you can get rid of the R's. So how many PBs do we have? Yeah, so we have 3 over 2 PB on the right hand side. The R's cancel, so, and let's add this, these two R's cancel, and let's add this half R bit to the other side. So we have 1 plus half R is going to be equal to 3 over 2 PB. So PB is 2/3 of 1 plus a half r. So PA is half times r plus 2/3 1 plus half r. Okay. What's this? So we get 2/3, and then how many r's do we have? Well, we have half an r here, and then we have half times 2/3 times a half an r here. So half times a half is a quarter. Quarter times 2/3 is 1/6. Yeah. So that's 1/6. you can write this as 2/3 plus 1/3. So who's pricing higher? Does this make sense? So firm B is pricing higher than firm A. Well, is R big or small? I don't know, is this intuitive? What do we know about R? We know R isn't too big and it's not too small. So if R was equal to 1, this should be symmetric. Unless something's... So I think we've made a mistake somewhere. Because if R is equal to 1, then they should both want to set the same price, right? They should both want to price it. It's just a standard problem, though. Can you see where I've made a mistake? So the exercise in the book doesn't actually ask you to solve doesn't, you know, so this isn't what the exercise in the book is asking you to do, so we can't look at the answer in the book. So what's the solution to these problems normally? So if you just had a standard hoteling model.
Tom, how have you still got 2/3?
Okay, so you've found where I've made a mistake, have you?
Is it because a half times 2/3
Oh, yeah.
can't be
That's isn't it?
2/3, it should be 2/6.
Yeah, so 1/3. That's one mistake.
Well,
And this is wrong as well, isn't it? So we had
it could be a half R plus a 6th R, so it would be
2/3.
yeah 2/3.
Easy to make a mistake here. Okay, so this makes sense now. So we've got 2/3 times a half, which is 1/3, and we've got half plus half plus a 6. So if R is equal to 1, this is 2/3 plus 1/3, which is 1. This is 1/3 plus 2/3, which is 1. Okay, that was a mistake. Well spotted. So this is symmetric when R is 1, if they set the same price as. If R is bigger than 1, okay, then this thing is going to be less than 1. No, if R is bigger than 1, this is bigger than 1. This is also bigger than 1, but this thing will be bigger than that thing, right? Because we're 2/3. Okay, so if R bigger than 1, PA is bigger than PB. Okay, so if R is bigger than 1, it means it's kind of cheaper for firms to go to the left. So given the choice, consumers would rather go to the left anyway. So it's increasing the monopoly power of firm A, so it makes sense for firm A then prices higher. If R is less than 1, then this thing, then it's the other way round, right? So R is less than 1, this thing is smaller than this thing. Okay, so PB is the higher price, and again, it's the opposite story. It's cheaper for consumers to go that way, so it's increasing the monopoly power of this guy. And you know, I suppose this solution is only valid if this inequality is satisfied. So, you could substitute in to find out what values of R this is satisfied for. So what do we need? We need naught is less than PA minus R. Okay, so that's 1/3 minus 1/3 R, 1/3 minus 1/3 R. And that has to be less than PB, which was 2/3 plus 1/3 R. And that has to be less than 1 plus PA, which is 4/3 plus 2/3 R. And you could, so you could solve this to find a range of values for R for which this problem makes sense. You know, so from this one, say this is going to tell you that R has to be less than 1. Yeah. This one will tell you. So you get 2 for the, yeah. This is not going. You should probably go if you're going to get to your next lecture.